for electrostatics, Neet. We will see some questions. See, here it is. You are given one right angle isosceles triangle, okay, having side A. Having side A. If net electrostatic energy of the system is 0, then you have to find what is Q. What is Q? Q is equal to what? See, right angle isosceles triangle means if it is T, it is also T. So yes, obviously according to Pythagoras theorem, it will become root 2A. Okay. Now, if net electrostatic energy, yes, for electrostatic energy, first of all you have to identify numbers of possible pair between charges. Yes, you are given 3 charges. So between these 3 charges, 3 pairs are possible. QQ first pair, QQ second pair, and this Q and Q third pair. Okay, so yes, in question of electrostatic potential energy, first of all you have to identify numbers of pair. Then what is equation of potential energy? Yes, U is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R. U is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R. With the help of this equation, you can easily find. Okay, see here we have 3 charges. Q, Q and Q. So yes, 3 pairs. So how to write electrostatic energy? See, if net electrostatic energy is 0, means U is equal to 0, total energy is 0. First of all, this pair, so I can say this K, Q, Q upon A. Then about this pair, it is plus K, Q, Q upon A. Then for this pair, it is K, QQ upon root 2A, and here it is equal to 0. Here is equal to 0. So see, here it is. Here it is. If we want to solve this question, how to solve this question? Yes, here KQQ upon A plus KQQ upon A. So yes, if I want to take KQQ upon A as common, then I can say this K. Here it is Q upon A common. In bracket, we will have only KQ upon A common, so it is Q plus this side it is Q. Okay, and plus here it is Q upon root is equal to 0. So yes, this Q upon A is not equal to 0. Means this one, that is Q plus Q upon root is equal to 0. Clear about this? Okay, yes, we have to find what is value of capital Q. Then how to find? Yes, I will take this minus Q on opposite side. Then it is Q plus Q upon root is equal to minus Q. Okay, so yes, Q common. So here it is root 2 plus 1 upon root 2 is equal to minus Q. So therefore Q is equal to, it is minus root 2Q upon root 2 plus. It is your yes, you have to identify pairs and write equation of potential energy for that pairs. Okay. Yes, KQ upon A, KQ upon A, KQ upon A common. So it is Q plus here it is Q upon root 2. So Q plus Q upon root 2 is equal to 0. So you will get Q is equal to, it is minus Q root 2 upon root 2 plus 2. Okay. Next question. See. A cylinder of radius r and length L is placed in uniform electric field E parallel to axis. The total flux passing from cylinder. See, if you are given cylinder like this, it is cylinder. It is cylinder. It is its axis. It is its axis. Okay. Now a cylinder of radius r and length L is placed in uniform electric field E parallel to axis. Means electric field is parallel to axis, means in this direction. For example, electric field is in this direction. Now cylinder means we will have 3 surfaces. First, second, and this third. Yes or no? Yes. It is first, it is second, and it is third one. Yes, we have 2 equations of flux. A flux phi is equal to, it is sigma 2 upon epsilon 0, and also equal to, it is integration E dot d. Which equation you have to use? It depends on given data. Which equation you have to use? It depends on given data. Here you are given object and direction of electric field. So obviously we will use this equation of flux. We will use this equation of flux. Okay? So chalo, for first surface, what is flux passing? What is flux passing? It is integration E dA cos theta is angle between E and dA. See, for first surface, cross sectional area is normally outside, means its area vector dA, it is in this direction. So for first surface, E and dA, they are in same direction, so it is cos 0. And we know that cos 0 is equal to it is, cos 0 is equal to it is, yes, it is 1. So it is equal to it is E constant, integration dA, it is circular, having radius r, so it is pi r square. Sorry, capital R square, it is pi r square. Clear about this? So phi 1 is equal to it is E pi r square. For second surface, this one, yes, its area vector is normally outside, means area vector dA is in this direction. So see, dA and E, they are in opposite direction. So what is phi 2? Phi 2 is equal to it is integration E dA cos 180. Cos 180 means it will be minus 1. E, that is again E, and area, yes, again its area is pi r square. Okay, what about third surface? That is phi 3. Just what about third surface? That is phi 3. Okay, for each and every element on this third surface, area vector is normal. Area vector is normal. So yes, for each and every portion, each and every element of this third surface, E and dA, they are perpendicular. So it is integration E dA cos 90. And we know that cos 90 is equal to 0. So yes, total flux y is equal to it is 0. Clear about this? Now, what is total flux? So total flux y is equal to it is phi 1 plus phi 2 plus phi 3. Okay, phi 1 plus phi 2 plus phi 3, it will become 0. It will become 0. Clear about this? Yes, in this case, flux phi is equal to 0 because electric field you are given is uniform. Electric field you are given is uniform, and this object is symmetrical. And this object is symmetrical. Clear about this? Okay. So yes, if you are given a symmetrical object and electric field is uniform within it, then flux passing from that symmetrical object is 0. Is 0. Clear about this? Now next question. See, you are given one wire which is uniformly charged. Its radius is 1 mm. Its radius is 1 mm. It is positively charged. And charge per centimeter of wire means charge per unit length. Charge per centimeter of wire is Q. Charge per centimeter of wire is Q for this wire. Charge per centimeter is Q. Okay, yes. This wire is enclosed by one cylinder having radius 50 centimeter and length 1 meter. Having radius 50 centimeter and length 1 meter. So your question is, what is flux passing from this cylindrical surface? Yes, again, flux. Equation of flux y is equal to sigma q upon epsilon 0, or it is integration E dot dA. Again, which equation we have to use depends on data given. Yes, here we will use this equation, that is phi is equal to sigma q upon epsilon 0. Now sigma q means charge enclosed by Gaussian surface. It is Gaussian surface. You have to find electric flux from cylinder. So yes, what is charge enclosed by surface? This. It is charge enclosed by Gaussian surface. Yes, it is charge enclosed by Gaussian surface. Charge on 1 meter of wire is charge enclosed by Gaussian surface. Yes or no? So how to find sigma q? Yes, how to find sigma q? You are given one relation. Okay, charge per centimeter of wire is q. So for 1 centimeter, charge is q. What is length of this cylinder? 1 meter. So what is length of wire inside the cylinder? It is 1 meter. 1 meter means 100 centimeter. So for 100 centimeter, what is charge? For 100 centimeter, what is charge? So obviously, sigma q is equal to it is 100 q. Sigma q is equal to it is 100 q. Clear about this? Again, charge per centimeter of wire is q. So for 1 centimeter, charge is q. So 1 meter means for 100 centimeter, what is charge? So sigma q is equal to it is 100 q. Clear? So yes, here it is 100 q and divided by it is epsilon 0. So it is equation of flux. So see, we have two different questions for flux. We have two different equations of flux. Sigma q upon epsilon 0 integration E dot dA. Which equation you have to use? It depends on given data. It depends on given data. Clear about this? Now we will see some next questions. See. Now next question, see, the electrostatic potential inside a charged spherical ball is given by phi is equal to AR square plus B, whereas distance from center, you have to find charge density inside the ball. See, the electrostatic potential is this phi is potential. Potential phi is equal to, it is A R square plus B. So what is electric field? Yes, electric field. Electric field. Yes, electric field E is equal to, it is minus d phi upon, it is minus d phi upon dr. Why d phi upon dr? Yes, you know what is equation of electric field. Remember, E is equal to minus dv upon dx or dv upon dr. Yes or no? Yes. So E is equal to minus d phi upon dr. So E is equal to, it is minus d upon dr of, what is phi? Yes, it is AR square plus B. So what is differentiation of AR square plus B with respect to R? It is obviously E is equal to, is minus 2AR. So yes, it is equation of electric field. Now we have to find charge density. Charge density means charge per unit volume. So first of all we have to find charge. Yes, we will find charge with the help of, yes, with the help of Gauss. That is integration E dot dA is equal to sigma q upon epsilon 0. Sigma q upon epsilon 0. Yes, E dot dA, E dot dA. Due to spherical ball, electric field is in radial direction, and yes, area vector is also in radial direction. So angle between them is going to be 0. What is electric field? Yes, it is minus 2AR. And what is value of dA? dA is 4 pi r square. dA is 4 pi r square, and cos 0 it will be 1. And charge enclosed by it, that is Q. Clear about this? So yes, what is this equation? Yes, so therefore Q is equal to, it is Q is equal to, it is 4 into 2. Yes, there is a minus sign. Okay, 4 pi epsilon 0. 4 pi epsilon 0. This is 4 pi epsilon 0, and remaining terms are, it is 2AR. It is 2AR. And now 4 pi epsilon 0 epsilon 0, and here it is 2a r into r square, means it is 5. So yes, it is charge, it is charge. Now you have to find charge density. So what is charge density? Yes, charge density, rho is equal to charge per unit volume. Charge per unit volume, what is charge? Minus 4 pi epsilon 0 2a r cube divided by, what is equation of volume? It is 4 by 3 pi r cube. It is 4 by 3 pi r cube. So see, it is 4 cut, pi cut, r cube cut, yes, this r cube cut. Then remaining answer is, yes, 3 is in numerical, there is always minus. 3 into 2, it is 6. So it is 6 epsilon 0 a. It is minus 6 epsilon 0 a. Minus 6 epsilon 0 a. Clear about this? So yes, this equation, which is based on two concepts. For first chapter, this one, Gauss law, and chapter number 2, that is relation between electric field and electric potential. Clear about this? So yes, it is one question based on that. Now next question, see, what is flux passing through a tube of side A if point charge of tube at its center, yes, we know that. See, if it is tube, and charge is placed at center Q, then yes, what is equation? See, this charge is at center, means this charge is enclosed by 6 faces. This charge is enclosed by 6 faces. Okay, so yes, here if I want to find flux, then what is equation? And phi of Q is equal to, it is Q upon epsilon 0. Simple. Yes, it is simple. But if I change this question, see, Okay, what is flux passing through a cube of side A if point charge of Q at its corner? Then what is flux? So see, we will see now some different cases. Okay, right now this charge is placed at center. Now if charge Q is placed at center of one face, means like this. If it is Q, okay, charge is placed here. So yes, I will ask you a question. Is this charge enclosed? No, this charge is not enclosed. So yes, first of all, we have to enclose this charge. And yes, this charge is enclosed if I draw another identical cylinder this side. Clear about this? Okay, then this charge is enclosed. So yes, here if I use equation, that is phi is equal to Q upon epsilon 0, but this Q charge is enclosed by 2Q. This charge Q is enclosed by 2Q. It is enclosed by 2Q. That's all no. But we have to find flux passing from only one Q. Then what is flux passing from only one Q? Yes, it is its half. That is Q upon 2 epsilon 0. That is Q upon 2 epsilon 0. Clear about this? Okay, so yes, if you are given one figure, charge is not enclosed, then you have to assume, or you have to enclose this charge by assuming one symmetrical shape. Okay, next question. If point charge Q is placed, at its one corner. Okay, then how to find flux passing from Q? Let's see. Figure is like this. Yes, it is Q. Okay, let charge is here. Point charge is here. Point charge Q is here. Then is this charge enclosed? No. To enclose this charge, you have to assume another Q. One this side, two behind these two spheres, and four above it. So if you draw total 8 cubes, then this charge is enclosed. Okay, so yes, if I find phi is equal to it is Q upon epsilon 0, then that Q upon epsilon 0 is for 8Q. Then Q upon epsilon 0 is for 8Q. And if you want to find only for 1Q, phi for 1Q, then it is Q upon 8 epsilon 0. Okay, anyhow you have to enclose that charge. With the help of symmetrical shape. Clear? See, in this question, it is flux passing from Q. But if I ask, okay, what is flux passing from one face? In this question, okay, in first question, okay, what is flux passing from any one face? So see, in cube there are 6 faces. Flux passing from cube means flux passing from total 6 faces is Q upon epsilon 0. So flux passing from only one face is equal to Q upon 6 epsilon 0. It is Q upon 6 epsilon 0. Clear? So it is question which is based on flux. For any shape, the questions may be asked that you have to solve. Clear about this? So yes, these are some questions based on electrostatics. See next question. Two identical charged spheres are suspended by strings of equal length. The strings make an angle 30 degrees with each other when suspended in a liquid of density 0.8 gram per centimeter cube. The angle remains the same. If density of material of the sphere is 1.6 gram per centimeter cube, the dielectric constant of the liquid is. Means initially these two spheres are suspended in air. Okay. So yes, case 1. Case 1. Two spheres, they are suspended in air. See, figure is like this. They have identical charges. See, two identical charge spheres. Identical charge spheres means if charge on one sphere is q, then charge on another sphere is also q. So between two like charges, there is always repulsive force. Between two charges, there is always repulsive force. And this force acts on line joining two charges. Yes or no? So repulsive force Fe, it is in this direction. Any doubt? Okay? Yes, it is. It is electric force. It is electric force. Yes, this force is acting on two spheres. On two spheres, Fe. But I will draw free body diagram only for one sphere. Yes, sphere having mass. So yes, Fe, it is in this direction. Okay, mg mass. Weight, it is always acting in downward direction. Let this angle is theta. Let this angle is theta. Okay, and tension produced in the string. Tension produced in the string, it is in this direction. That is T. Okay, see this Fe, mg, and T. Forces acting on sphere. Forces acting on sphere are mg, Fe, and T. Out of these three forces, Fe and mg, they are in vertical and horizontal plane. So yes, we have to resolve this T in two components. We have to resolve this T in two components. If this angle is theta, this angle is also theta. So it becomes T cos theta and it becomes T sin theta. And for equilibrium, in equilibrium I can write in equilibrium. How to write in equilibrium? Yes, Fe is equal to T sin theta. Yes, Fe is equal to T sin theta and mg is equal to, yes, mg, or you can say this mg is equal to W. That is right. So yes, that W is equal to, it is T cos theta. Any doubt? Okay. So if you take the ratio, Fe upon W is equal to, it is tan theta. Equation number 1. Equation number 1. Clear? Now I am assuming density of sphere is rho. Density of sphere. Density of sphere is rho. Then I can write W is equal to mg and is equal to, it is rho Vg, where V is volume of sphere. Any doubt? Okay. Initially, these two spheres, they are suspended in air. Now the same two spheres are suspended in liquid. So yes, case 2, they are suspended in liquid. They are suspended in liquid. So again, we have to draw figure. Yes. Again, we have to draw figure. They are suspended in liquid. Yes, it is liquid. Okay, it is liquid. They are suspended in liquid. Then what happens? See, these two spheres. These two spheres. Again, forces acting on spheres. See, you are given this angle theta same. Okay, the angle remains the same. Means this angle theta is same. Angle is same. What about forces? Yes. Forces acting on sphere, there are three. Fe, that is electric force, weight and tension. Electric force, weight and tension. We know that when medium between two charges is changed, electric force also changes. So now electric force is, it is Fe dash. It is Fe dash. Clear about this? And what is value of Fe dash? Yes, Fe dash, we know that Fe dash is equal to, it is Fe upon K. Remember, when air is replaced by another dielectric medium, force acting between them is Fe dash is equal to Fe by K. What about weight? Yes, weight is acting in downward direction. Weight of object in one medium is different than weight of object in another medium. So what about W dash? Yes, W dash is equal to what? Weight in another medium means what? Remember 11th fluid mechanics, beyond force, what is weight? We have already discussed. Okay, my students, W dash is equal to, it is W1 minus, W dash is equal to, it is W1 minus, it is rho 0 upon, it is rho 0 upon, yes, it is rho 0 upon rho, where what is rho 0? Rho 0 is density, rho 0 is density of liquid, rho 0 is density of liquid. Now, from where this equation comes? Yes, W dash is equal to weight of object minus weight of object minus weight of object means rho Vg minus beyond force, that is rho 0 Vg, that is rho 0 Vg, if you remember. Okay, weight in any other medium is equal to weight in air minus beyond force. So it is equal to, if you take rho Vg common, it is 1 minus rho 0 upon, it is 1 minus rho 0 upon rho. And what is rho Vg? Yes, it is W. So it is W 1 minus rho 0 upon. Okay, so here W dash is equal to this. Clear? What about tension? Yes, tension, it is T dash. But don't worry about tension. Again, we can resolve this tension in two components. This angle theta, T dash cos theta, it is T dash sin theta. Again, for equilibrium, in equilibrium, I can write Fe dash is equal to T dash sin theta, and W dash is equal to, it is T dash cos theta. So yes, Fe dash upon W dash is equal to, it is tan theta. Equation number 2. Now compare these two equations. So see, here it is. Fe upon W is equal to Fe dash upon W dash. Okay, so yes, Fe upon W is equal to, what is Fe dash? Yes, it is Fe upon K. Or yes, you can write it as Fe upon K. What is W? So W is equal to, sorry, W dash is equal to, yes, it is W 1 minus rho 0 upon, simple, yes or no? Fe cut, W cut, W cut. Okay, so if I take this K this side, if I take this K this side, then K is equal to, it is 1 upon 1 minus rho 0 upon, K is equal to, is 1 upon 1 minus rho 0 upon rho, where rho 0 is density of, yes, what is rho 0? It's density of liquid, and what is rho? That is density, rho 0 is density of liquid, and rho is density of sphere. So if you put these values in this equation, okay, see how to put. K is equal to 1 upon 1 minus rho 0 means density of liquid. What is density of liquid? It is 0.8. It is 0.8 divided by density of sphere, it is 1.6. So yes, 0.8 upon 1.6, it is obviously 1 by 2. So yes, it is 1 upon 1 minus 1 by 2. 1 minus 1 by 2, it is 1 by 2. It is 1 divided by 1 by 2. So your answer is this 2. So your answer is, it is clear. Now, I have solved this question for you. You have to remember this equation only. You have to remember this equation only. See, there are three variables. K, that is dielectric constant, rho 0 density of liquid, and rho, that is density of sphere. Rho, that is density of sphere. Out of these three, 2 will be given, another you have to find. So yes, if you remember this equation, then you can solve such questions easily. And yes, this figure and this equation, that is Fe upon W is equal to tan theta, that you have to remember, because from this case there are another questions that you can solve with the help of this equation. Clear? So yes, under electrostatics, this is it for today.